Every day, thousands of New Yorkers cross the Main Concourse without knowing what lies beneath their feet. 2 more levels of railroad, 67 tracks, miles of tunnel, a switching system built to move trains without anyone seeing them move. None of it was supposed to exist. Grand Central was never meant to disappear completely below the street. It was forced there by a single morning in January 1902 when steam and smoke turned a tunnel into a tomb. By 1900, the New York Central Railroad was running hundreds of steam locomotives into Manhattan every day, arriving at a rate of roughly 1 every 45 seconds, funneled through the Park Avenue Tunnel toward Grand Central. The tunnel had been built decades earlier to get trains off the street. Instead, it trapped their smoke. Visibility inside dropped to almost nothing. Signal lanterns vanished behind a wall of soot and steam, and engineers were driving blind through the heart of the city. On January 8, 1902, an express train missed a stalled signal in the darkness and struck a commuter train waiting ahead. 15 people died at the scene, and 2 more in the days after, raising the toll to 17. The wreck forced a question no American railroad had answered before. How do you remove an entire railroad from the surface of a city without removing the city's biggest train station? William J. Wilgus, chief engineer of the New York Central, had already been considering electrification before the crash. But the disaster gave him the leverage to act. Within months, he proposed something no railroad had attempted at this scale. Tear out the old depot entirely, sink the tracks underground on 2 separate levels, and run the operation on electric power instead of steam. He had spent years inside those tunnels, watching how trains queued, stalled, and fouled each other's paths. He understood the bottleneck because he had stood in it. The plan began with excavation on a scale Manhattan had not seen. More than 10,000 workers cut through bedrock and earth to an average depth of 50 feet below Park Avenue, removing close to 3 million cubic yards of rock and soil. None of it could interrupt the trains still running above, so blasting happened only at night, and crews stopped work every few minutes whenever a train needed to pass. The job crept west across the site in sections, one finished before the next began, so that not a single scheduled train was ever cancelled for construction. Wilgus laid out the new yard on 2 distinct levels, an upper deck for long-distance trains, a lower deck for commuter traffic, both threaded with loop and circulation tracks that let locomotives turn and depart without backing out. None of it worked without solving the power problem first. Wilgus rejected overhead wire, which was vulnerable to ice and collision, and chose a 660-volt direct current third rail instead, mounted beneath a protective cover so a stray hand or tool could not reach the live contact from above. If the third rail drifted out of alignment, a locomotive's contact shoe could lose contact with it, risking a stalled train in the dark, in exactly the kind of spot where the old disaster had happened. Every joint in that rail had to hold tolerance across miles of curving track, underground, at a scale no American railroad had built before. On September 20th, 1906, the current was switched on for the first regular electric run. A locomotive rolled onto the third rail. No smoke, no steam, no exhaust. Just the electric hum of the motor and the roll of wheels on rail. It pulled out of the tunnel and into daylight, clean. For the first time in the history of the New York Central, a train had left Manhattan without burning anything to do it. Engineers timed the run in silence. Then they wrote down the results and kept building. Electrification solved the smoke. It did not solve the traffic. The new underground yard was built around continuous circulation, loop tracks, storage sidings, and signal junctions that let arriving trains turn and reach the yard without reversing through a switch by hand, one of the more dangerous routines in the old tunnel. The new yard could hold 1,149 cars, triple the old station's capacity, eliminating the 5-mile deadhead run crews once made just to clean and store equipment. At opening, the The shed held 123 tracks including storage sidings, totaling 19.5 miles of rail, almost entirely out of public view. By the time the terminal opened, most of what made it work was already invisible. The switching crews, the signal towers, the men keeping 67 tracks from colliding in the dark. None of it could be seen from the main concourse above. On a busy day, hundreds of thousands still pass through. Most have never seen a single track below the upper level, let alone the second city running beneath it. The skill in this system is invisible by design. Because the upper and lower levels use different track layouts, the support columns beneath Park Avenue rarely lined up between floors. Each column carrying the weight of the street, the buildings, and the trains above had to be engineered individually, some bearing loads of nearly £2 million, transferred through girders engineered for bending moments in the millions of foot-pounds. None of that shows on the surface. A pedestrian walking up Park Avenue today is standing on a column grid that took 10 years to calculate correctly. It only had to be right once. Burying the tracks did something no one had fully planned for. Once the trains ran underground and clean, the land above them became buildable for the first time, with nothing but steel columns and rail below. The railroad began selling air rights over its own tunnels, and a new district rose around the terminal, Park Avenue's apartment houses, the Biltmore Hotel, and a wave of towers that followed, including the Chrysler Building a few blocks away. The terminal had not just solved a transportation problem. It had manufactured real estate out of empty air and changed what the center of Manhattan was worth. By July 1908, New York state law barred steam locomotives from the Park Avenue approach into Grand Central, finishing what the crash had started 6 years earlier. The system Wilgus built did not vanish. It has been expanded and modernized many times since, but it still runs on the same logic he laid out. Electrified, multi-level, built to move trains without anyone needing to see them move. The question from 1902 had a one-word answer: down. Wilgus solved it not with a single invention, but with a layered system. Electrification, a 2-level track plan, individually calculated columns, and a real estate scheme that paid for all of it, built to disappear from view the moment it worked. The main concourse above was always meant to be seen. The railroad beneath it was built to be forgotten by the very people who depend on it most. This is the kind of system most people walk over without ever knowing it is there. If you want more of these hidden engineering stories surfaced, consider subscribing, and tell us which forgotten system we should uncover next.